Master Academy of Mathematics, and this is your Dr. M. Srinivas. Today we are going to think about one more assignment. This assignment is based on the video lectures from part number 10 to 15. So corresponding to that, if I look on to the first one, just I give you the brief idea how to find out the solution corresponding to the assignment problems. If I look at the first one, find the circulation, that is also called as work done, of a vector point function along the circle x square plus y square equal to 4 in xy plane. So clearly it is mentioned xy plane. What do you mean by work done? Indirectly you are calculating the line integral of the corresponding vector point function. So line integral formula is integral over c f bar dot dr bar. So mentioned clearly f bar. Write down r bar is nothing but xi plus yj plus zk. Dr bar equal to dxi plus dyj plus dzk. From that, first you calculate f bar dot dr bar. In that, after getting that simplification, since it is given xy plane, z equal to 0, that implies dz equal to 0. So that values you substitute in f bar dot dr bar and directly you make the simplification. Now in order to get integral over c f bar dot dr bar, everything should be converted into a single variable. In order to get the limits, they have given the circle equation x square plus y square equal to 4. So in order to convert into single variable, better you convert into trigonometric functions. Let x equal to 2 cos theta and y equal to 2 sin theta, so that you calculate dx value and dy value. So everything it is converting into theta, where theta is taking the values from 0 to 2 pi in the circle. So with that you will get an answer. Final answer is 8 pi. Okay, the first bit. Similarly, coming to the second problem, if f bar equal to some vector function is given, then find integral over c f bar dot dr bar, where c is nothing but it is a rectangle in xy plane bounded by y equal to 0, y equal to b, x equal to 0, x equal to a. So again they are asking only the line integral. So in order to get line integral in xy plane, already z equal to 0, from that dz equal to 0, you just simplify first f bar dot dr bar and you keep aside. Now in order to get the complete line integral corresponding to a rectangle, first you construct one rectangle in xy plane with the values y value 0 and b, x value 0 and a. You will get one rectangle. So that rectangle complete line integral is the combination of 4 lines. You will get O, A, B, C. Like that you just calculate individually the line integrals corresponding to the 4 lines. Combine all those 4 line integrals, you will get the complete line integral corresponding to the rectangle. The answer is minus 2ab square. Okay. Coming to the third one, find integral over c y square dx minus x square dy around the triangle whose vertices are given 1 0 0 1 and minus 1 0 in xy plane. So again asking to calculate the line integral only. Clearly it is given f bar dot dr bar is already is there. Corresponding to that, to get the complete line integral over the triangle, I just given one hint also. You just look at based on the given vertices of the triangle, you are just constructing a triangle in xy plane, so that we are having a to b, b to c, c to a. 3 lines are possible corresponding to the triangle. So to get the complete triangle, better you write down the line integral corresponding to AB and BC and CA. Add all those 3 line integrals. You will get the complete line integral of the given triangle. Okay, are you getting the idea here? Right. Coming to the next one, fourth problem. They have given f bar, a vector point function, asking to find out integral over c f bar dot dr bar, from the point 0, 0, 0 to 1, 1, 1 along the straight line from 0, 0, 0 to 1, 0, 0 to 1, 1, 0 and 1, 1, 0 to 1, 1, 1. So these are nothing but the different points they have given. Look at the given problem. You just identify the different types of problems. Here it is, hint is given, O 1, 0, 0, 0. A point is given, B point is given, some C point is given. Now they are asking to find out the complete line integral from first point to last point. So in order to get that value, I am just adding all the line integrals from O to A to B, B to C. And you just combine all those line integrals, you will get the final answer. Okay. Just you look at the video lectures, you will get the idea also corresponding to the line integral. Now I am coming to the fifth one. Integral over C, some function is given over x equal to a cos t, y equal to a sin t, z equal to kt, and t varies from 0 to 2 pi. So already it is given a line integral. So f bar dot dr bar, they have made simplification. So x value, y value, z value they have given. Better you calculate dx value, dy value and dz value. Substitute those values in your f bar dot dr bar. Everything is converting into t variable. The t limits they have given 0 to 2 pi. Do the simplification. The answer is 0. Okay. Now coming to the next one. Find integral over C f bar dot n bar ds, asking surface integral where f bar is given and s is the surface with 2x plus y plus 2z equal to 6. So as I told you in the video lectures, to find out the surface integral, the first thing is nothing but to decide which plane you are taking, either xy plane, yz plane or zx plane. Since there is no restriction, here it is, only surface equation is given, you can choose any one of the planes. Better you select xy plane first. In xy plane, remember that z is equal to 0. So from that you will get one surface equation. But before going to that, already f bar is given. Find out first n bar. So how to calculate n bar? It is nothing but unit normal vector. In order to get unit normal vector, use the surface equation as it is and directly you are converting into a vector by applying the gradient, and for that vector you find out the unit normal vector denoted by n bar. After getting that n bar, find out f bar dot n bar value. Okay, now if you are taking xy plane, the formula is nothing but integral over xy plane f bar dot n bar dx dy divided by modulus of n bar dot k. So you calculate n bar dot k value, you will get one answer, and that values totally you are substituting in your given expression of xy plane, and you substitute all the values, and in order to get the limits, double integration, you look at the surface equation where xy plane z equal to 0, from that 2x plus y equal to 6, from that you calculate y equal to 6 minus 2x, so y limits are 0 to 6 minus 2x, then you substitute y equal to 0, you will get x limits which are nothing but 0 to 3, and substitute those limits, and just you make the simplification, you will get your final answer is 81. Okay, just you practice it. And a problem is given phi, which is 45 x square y, asking integral over v phi dv. So already only phi is given, scalar function they have given. Dv stands for dx dy dz. So indirectly they are asking, it is a closed region bounded by some equation is given. We need to calculate the volume integral. So volume means it should have three integrals, three variable limits. From the equation 4x plus 2y plus z equal to 8, write down first z equal to 8 minus 4x minus 2y. Z limits 0 to that value. Substitute z equal to 0, you will get y limits. Next y equal to 0, you will get x limits. Do the triple integration, answer is 128. Right? Now you are using Green's theorem. A problem is given. Use Green's theorem to find out this value. So where C is the region bounded by x0, y0, x plus y equal to 1. In order to use Green's theorem, as I told you, if they are asking line integral, you convert into double integral. If they are asking double integral, convert into single integral. So already asking to find out single integral, better you calculate the double integral value. But before going to that, is it looking like mdx plus ndy? Yes. Identify m and n, and you just find out double integral formula is dou n by dou x minus dou m by dou y of dx dy. So we need to have two limits, x variable and y variable. X limits, first you find out y limits, y0, and another from the equation y equal to 1 minus x. There y equal to 0, then you will get x limits are 0 to 1. Write down, simplify it, you will get answer is 5 by 3. Verify Stokes theorem for f bar equal to some function is given. You need to recall your Stokes theorem. Stokes theorem left hand side is integral over c f bar dot dr bar, and the right side is nothing but your right side integral double integral over s curl of f bar dot n bar ds. So before going to that, here also you just think about first individual calculations. If you want to calculate the left side integral, f bar is given, write down dr bar, but before going to that, you select any one of the plane. Since there is no z variable in f bar, better you suppose xy plane. From that z equal to 0. So the limits here it is given, but we have to calculate only one single integral. So for that x value 0a, 0b is given. Some x value 0 to a and y values are 0 to b. So indirectly, this is nothing but you are constructing one rectangle in xy plane. On x-axis 0 and a you are locating, and y-axis 0 and b. From that you construct one rectangle. So it is nothing but a combination of 4 lines. You just find out 4 line integrals and combine it, you will get left side integral. To get the right side integral, it is curl of f bar. First calculate curl of f bar. N bar is nothing but, remember, here n bar you need not calculate. In xy plane, perpendicular axis is nothing but z axis. Corresponding vector is, it is k. So directly n bar is equal to k only. Find out curl of f bar dot n bar. Here dx dy. Directly you substitute that values and do the simplification. The limits are 0 to a, x limits, y limits 0 to b, and you will get the answer 2ab square. In both the cases you are getting the same. Now let us have the last one. Use Gauss theorem to evaluate integral over s f bar dot dn bar f bar dot n bar ds, where f bar is given over x equal to 0, y equal to 0, z equal to 0, and x plus y plus z equal to 1. So asking to find out the surface integral, you recall your Gauss theorem. Left side is integral over s f bar dot n bar ds. Right side is nothing but integral over v divergence of f bar dv. So for your surface integral, you better you calculate your right side volume integral. F bar is given, you find out the divergence of f bar, you know how to calculate it, and dv stands for, it is dx dy dz. You need to write down 3 variable limits. So use the equation x plus y plus z equal to 1, z equal to 1 minus x minus y, z limits 0 to that, and y limits, to get y limits substitute z equal to 0, you will get y limits, and x limits can be calculated by supposing y equal to 0. So that you, totally the final answer is 1 by 8. So this is how I am just based on that video lectures part number 10 to 15. I am just giving you certain problems, important problems, and that you can expect even in the final exam. So you can have an idea to use your complete video lectures one by one. So before going to that, I am just giving you these tips so that you can find out your solutions one by one. Require your patience and practice and knowledge concentration on your video lectures. So thank you. फिर मिलेंगे with the next video session.